meal, to get it cool, they wouldn't have had to go out for a walk, and there wouldn't be any problem. And so this is a wonderful solution to the issue of the three bears. Of course, it destroys the story, but it's still a great scientific issue to the three bears. But we do have this problem.
Did you ever worry about this when you told this story to your children? Doesn't it disagree with your sense of thermodynamics?
The big bowl, those of you who aren't familiar with it, the big bowl, they come back.
He says,
well,
big bowl's too hot.
The big bowl's too hot.
Medium bowl's too cold.
And big bowl is daddy's, medium bowl is mama's, and baby's bowl is small.
So you have a sheet of paper. Could you write down, do you think this could be true? I mean, I know, but has the science in the story ever worried you? How could the porridge? So can you write down how it could actually happen in real life?
You might want to talk a little with each other. There are explanations that would account for this.
Well, maybe there are a few hundred. So why don't you write down your individual solutions to the problem? The thermodynamic problem. Even if you're not a scientist, you might be able to come up with a solution. We're all scientists. Please write it down on the sheet of paper provided, because we'll collect the sheet at the end of that. When you have a talk with your neighbor, see what they say.
You start with common part.
Right now, you're really interested in the solution. Come on, where's your... You consider it I'm really interested in seeing if everybody has the same. Kalamazoo, maybe there's a unique solution to Kalamazoo.
Well, let's start seeing, should we start seeing, Gordon, we've got some answers? Should we start seeing what kind of answers people are getting?
Yes? Anyone have an answer they want to tell us? Anyone ready to publish? Yes? Yes?
The bowls have different thermal conductivities.
One?
The bowls have different thermal conductivities.
The bowls have different thermal conductivities, so I would say that that's a solution where the material of the bowl is different, right, of each one. Agreed? That could work. Any other solutions?
You've got Mary's solution.
Nora, you can't solve this problem? You have to go back to first grade. Yes?
Before they left, Mom went to the refrigerator and pulled out great ice cubes and cool off the porridge. So we put tons many in there so we keep back as it's cold.
Great.
Okay, so what's that method of preparation, right?
No, well, that's the contents.
Yeah. Oh yeah, that's contents, right? Yeah, right. It's what happened after it was prepared. Any other different solution?
Yeah, you had one?
Yeah, so she knows Papa Bear likes his porridge hot, so she stuck it in the microwave a bit longer in the thermos jar. She likes hers cold, so she added ice cubes, was my solution. And Baby Bear's was hot when it was off the stove, and she just left it, and it's been cooling since. So it's just the right temperature when it's cool.
So I call it, maybe that's a method of preparation, right?
Well, I called it sort of the agency, what she did to each of them.
Maybe, yeah. Any other?
My partner had a suggestion that shape could be different.
The shape of the bowl. Very good, right? So what were you thinking? Big wide one and the little narrow one? Yeah. So the shape of the bowl?
Yes.
Any more?
You've got Mary's solution.
We have lots and lots of answers to this question. Did we both question?
What was your
Alan, could you tell what Nora couldn't?
I would say that you haven't specified the initial.
You haven't specified the initial conditions. Okay. Different initial conditions Right? So what could be an initial condition that was different?
Before first, how long was one cooling for a longer time than the others?
Yeah, so time of starting to pour, right, or something. So time, I mean, that always seemed to me the simplest answer, right? They were prepared at different times. Any other?
Yes.
Call it Mary's solution. Mama
Oh,
Bear
right,
put
near the window.
Okay,
Position, location.
okay.
I think we got a lot of them. See how many answers there are? And so you could go on and discuss. If this was a graduate physics class, we could actually develop some theories of cooling or something, or develop. You could move this, or if you're in the first grade, you could start talking about things. Oh, sorry. Yes.
Like the different brands. It can be
Different brands.
different brands.
Oh, different types of porridge,
Oh, okay.
or oatmeal. One was oatmeal, one was sausage rolls. Or
A pre-K class were recently discussing it. They were mostly Mexican English second language learners, and they just said that it was sopa, which means soup, and Papa's had lots of chili in it, and Mama's had a fair amount of chili, and Baby's had no chili, just like they like it. And so it was hot in a different sense.
yeah, spicy, right?
Yeah.
And in a colloquium in Notre Dame, one clever graduate student suggested, well, some were radioactive and the others were not. Okay, what's next? Well, you say you did finish that. So, Mary, you're on.
Okay, so I'll do this and you can do the next one. So the first aspect of guided inquiry is what I call the 3 E's. The first thing you have to start with is engagement. You move on to exploration, and finally you come to evaluation. So engagement is triggered by posing an interesting open-ended question. Does this sound familiar? We're back at where science and literature both start. What's this interesting open-ended question about a specific problem that does not have a unique solution? But one would hope it has an elegant solution. And whatever solution you come up with, it has to be well supported. And Gordon, you're going to go into exploration for us.
Yes. Exploration. So we're going to give you an opportunity to explore now, because that will be the second part of the classroom. Once you pose the question, or the class has posed the question, you want to make a measurement. And so I've handed out 4 little devices. They're really remarkable devices, these. They look like a video game, but they measure magnetic field. Right? Is that correct, sir? Yeah. So while we continue the class here, I want each of you who has one of these to spend a couple of minutes, measure the magnetic field, and then pass it on to your neighbor. And perhaps we'll have about 10 magnetic field measurements before the end of by 6 o'clock.
And what you want to do is
be wrong.
you want to record what you find your
So
measurement.
just a couple of minutes, write down your result on your paper, and then we'll go on.
And so you can see that exploration really means that we draw on prior knowledge and experience. We use a methodology appropriate to the discipline. So here we're talking about physics. If I'm solving a math problem, I have a different methodology. If I'm solving a literature problem, I have another one. And my role as the teacher is to facilitate, is to guide that inquiry, and to use my understanding. I probably have begun by structuring the problem somewhat, and then I guide the inquiry so that the learners are moving in a way that's going to be productive. And finally, evaluation is what you are doing, those of you who are research scientists are doing all the time, right? The evaluation is not the test at the end of the class. The evaluation is intrinsic. It's a question that the inquirer asks themselves.